And we're live.
Probably because we're downtown, it's probably getting us to a parking spot.
So you said there was food where?
Straight that way.
That way. Gotcha.
There.
Yeah.
A restroom, I think there's a restroom.
Yeah.
Right there. May I use it?
We have to get a key.
Okay.
Either that, you have to put in like a box.
Yeah, I used to work on 4th Street Live in our building. Always had keys for the bathrooms.
Yeah. It's weird. Although some people, and they're shaking. Although we got a call from China last night. I have no idea if they weren't speaking English. Is it racist? Yeah, probably. What do you mean? I don't know what the joke is. Yep, China.
Yeah.
I thought the guy was speaking Chinese, but not really. It was pretty pissed off. I felt like twice.
I emailed you guys the link.
To the game.
Yeah.
Okay.
7 o'clock and 7:25.
Hey, Eric, do you want to tweet out the link to the game to Parsons? And do you want to put out the link to my GitHub with all the stuff in it now? You know what?
I was tweet the link, but don't put at yours because then all our players will jump in.
Yeah.
I find a tweet with Parsons.
Sorry. Get into the meetup.
Then I was going to send you the link to my.
Opposite those ski. Better. Like, I
Yeah.
like better.
If you just mention it over
That's fine.
Okay, I'll just tweet out the.
Like, I use the
Oh, sweet.
music.
But I think on my phone, that's my email.
More like German beer? Yeah, I think more like German beer. More like German beer. Something different. But like, yeah, it's like German.
See, this whole American trend toward super hoppy IPAs and triple IPAs and APAs. Give me a good Belgian dark strong. Malty and yummy and filling.
Yeah.
Real beer, right?
It would be allowed I can drink something in December. Oh
my God. Yep.
I'm not sure.
I work in this place in Idaho.
Yeah, it's a lot.
They are a infrastructure as a service. They offer queues and workers.
Where are they based?
San Francisco.
Nice. What do you do?
I'm a customer support engineer. So I report to the VP of sales, but I also do like not really customer onboarding. I guess you could say it's tech support, but you know, in a more complicated way.
That sounds good. How'd you learn?
This guy that I know online, I was like, hey, recommend me to some place.
You got you?
Yeah, and they were hiring.
Good, makes
So,
sense.
did a couple of video interviews and video chats.
The remote work gigs are the best, aren't they?
Well, this is my first one.
Oh.
I've only ever worked at home 2 days so far.
Ah.
I don't know. Maybe.
I'm on my third work at home gig. I've been doing it off and on for about
Do I know you?
Devin
Devin
Phillips.
Phillips. My name is Kyle.
I've seen you on Slack, but I don't think we've been introduced in real world.
What's going on?
Not too much. Just trying to eat this before I drip it all over myself.
What's in it?
Spinach and veggies and I don't know,
some other stuff. So you're on your third remote gig?
Mm-hmm.
Kind of, I'm doing some contract work.
Yeah, back in
Breaking into technology.
2009, I started working for DNS.com. I stayed there for like 2.5 years,
Okay.
working remote. And then I did a short stint at Heartland. Don't recommend it. And now I work for SunGuard Availability Services, and my closest coworker's in Georgia. So
Yeah, I don't work on the real hardware. That's I'm on Mark's team. Making.
oh yeah,
We went to Cook Blues. Like, we don't do normal.
yeah. Secure Submit is their own special entity.
Yeah. Yeah, when they tried to put us onto an agile release train,
Yeah.
the past couple months, and then now that release train's going right at our location, so we're all back to normal stuff.
Heartland doesn't do Agile. They play it doing Agile. That was one of the reasons I hated Heartland.
Agile's whatever you say it is.
They seem to think so.
It was like
Agile to them was fill out all of these stupid ass reports in Rally so that we can make metrics to show the VPs.
it was like a dagger ball.
There was nothing agile about their implementation. I think most people call it Agifall or something like that. It's waterfall with an agile veneer. Look, we're using Web 2.0 tools.
I've heard of that.
It's sad.
When we get to Web 3.0, that's where the money is.
Web 3.0 is already here. That's what all of these event-based websites is all about. WebSockets and WebRTC, and that's Web 3.0.
What's the web version where I just like fall and I step in tracks? That's the one. That's the version I want to get.
Unless you were around for the
Well, on Twitter, can get it?
Yeah, I'm working on this.
Not bad.
Sometimes.
I was disappointed I couldn't make it back last week.
Yeah.
Kid was sick and teething.
I was just
That's right. Points just on there.
How old is it?
Based on that.
Yeah, I think it's just a points game. I didn't check it out. Mark built it.
You talking it?
Give him water.
Yeah, I'll take a water. Thank you.
Hey, that was good. I'm appointed. I'm happy about it. I'm still getting used to it.
What is that?
The training wasn't. It could have been better. The other guys were leaving, so like, hey, let's train real fast. Bye. But he's not there now. Ask questions.
It's always bad. Looking at like Rails and craft up some questions from you.
Some of the tools are in there, so I have to install it so that I can run a couple of. Most of the stuff is a lot of the stuff to the web interface, the web admin, I guess. But then there's at least one thing. So, yeah, so I'm like in the middle of installing. I still haven't gotten further. I was trying to install libv, so it's failing on compilers. So I switched to GCC, and it's failing on other compilers.
The system.
For anything.
So I'm gonna have to learn some of that stuff. Some of the that's popular languages.
Wherever we start, so.
Like that. I have no idea what that was. Somebody else.
Yeah. What do you do there?
So it's a infrastructure for sell the products that they have for message queues and then workers. You get the worker it comes to the message.
A lot of some of
It is a copy. Yeah, that's the company. Iron Mountain, Landing Machine. Yeah. And then the workers are just,
they're different.
they're just doctors.
Barrier. Yeah. It's just different.
Still amazes me that so few people know about Docker yet already. It hasn't really pierced the non-startup businesses yet, it seems like.
I talked to a guy
Yeah,
a couple of weeks ago.
guys wants to.
He was leading a mentorship at Code Blue.
His
Day job was at GE. And he said they just stood up a whole bunch of Docker instances
And then
on
he ended up
using
doing
Kubernetes
and
and Mesa, Mesa or
Miso.
Miso, using that for a stack. I don't know exactly what they do or what his department is, but it was leading the Rubio mentorship.
Interesting.
But other than that, yeah, I've heard about bigger places being interested in this. Sort of reading about like, what's so special about Docker? This company, they're going to do all this awesome things. But they're doing
Yeah, because my company, we do infrastructure as a service and disaster recovery as a service. So virtualization is our thing.
Yeah.
So Docker, like, as soon as it started to get any traction whatsoever, it was in the door.
So have you had any customers ask about it?
We have lots of customers using it,
Oh, really?
but they're all like startup style customers.
Not the bigger ones?
Not yet. I mean, we've got a lot of Fortune 50 companies using our services, but none of them are using Docker yet.
Yeah.
After the presentation, that's the first time I've seen one put it.
You must be present to the.
Well, that's because
we're eating the
programming numbers, that'd be a little harder.
Doing the bigger thing.
I guess it would be.
Just one?
Like a
Beer is the applied world.
May make me feel bad, all right? This is good.
Is that for the books? Yes. Yeah, I've got them all already. Thank you, though. Let somebody else have a better chance.
Can I pull your number also?
Yeah, I can draw a number and give it to him.
Yeah, give it to the recipient of your choice.
There you go.
I'll just give it to him. He was the first one to mention it. He was the smart guy. Uh-oh, my wife's calling. Pardon me.
Oh, yeah?
Okay.
So we actually, I talked to one of our customers that uses yeah, so I feel like I have to sit down and learn everything.
Yeah, I mean, yeah, somebody.
Yeah.
So is Elixir its own syntax or compiled down to run the
It compiles into the same thing.
Okay. Can you?
So it's kind of like Java installer. So they are the same. They run on the same but they have different syntaxes. Kind of like things everything that you can it's nicer wrapper.
Can you? What's
It's hard, I tell you what, you have this guy who has it's a truthfully like cool tool. Yes, there's gonna be a you can tell that's
So then let's say you're writing something and you have like small, writing something in Elixir and it's like in one file or physical that one file.
And then I've always something has a
I know I'm not easy to
you pull us in.
I try to always play.
Hey!
Go see what
Okay,
I'm changing.
like in a beer city. And people will argue. Someone may know so you pay. So that's not fair. So.
Yeah, I guess so. I hadn't
It's hard to do it that way. You gotta be on there. I would
In my view, it's like, I see gas every 5 seconds. Horse race.
I did that.
No, it's great.
That is not
yeah.
I figured out how it works.
Is there a better place I can put this camera to see that screen? Is the question.
Well,
Yeah, but that's gonna strangle people.
If you stand that way, the time.
Yeah, that's gonna happen. Apparently killed the camera now.
it's kind of looking on to see if, we had a lot more people sign up, but don't want to get started here in a few minutes.
Yeah, it's not quite reach.
Yeah.
But stop.
All right, so guys, go ahead and get started. That's all right with everybody. Thanks for coming to our first meetup. This is our office. Our company is called Horse Racing Labs. So we own Horse Racing Nation and Derby Horse. Our tech team kind of hangs out in there. Primarily, we were brought in to work on Derby Horse. Derby Horse was originally written in Ruby on Rails about 3 years ago. The site's grown quite a bit since then. So when we first started, the site was crashing and having all kinds of problems, and we fixed that. But then we were thinking about building a new version. And so as we started doing that, we thought about trying to make Derby Wars much more game-like. And just so you understand what Derby Wars is, I should probably tell you that. It's super important. It's a daily fantasy sports site for horse racing. So if you guys are familiar with fantasy football, things like that, we did the same thing with horse racing. And actually, after the presentation, we put together a free game for you guys if you want to play. I tweeted out a link to it. It's just for you guys. So we can talk about that later if you have any interest in it. But the things that we liked about Elixir is that it would help us run a lot more games, and really scale up. And the business has been growing quite a bit, so we felt like it was the right technology choice. I'm not passing myself off as Mr. Elixir, that I've been doing it for 6 years, because it hasn't existed for 6 years. But we've been learning it, we've been building out, prototyping some things in it, and so we wanted to bring in a broader community, and so that's why we started the meetup. So our first meetup, we're doing an intro to Elixir, so don't expect any super advanced topics. We just want to kind of cover the basics with you guys, get some interest. After the presentation, install Elixir on anybody's laptop who wants it. There's also, I have some links in the end of the presentation. So there's a thing called Elixir Playground where you can just run it through a web browser too. So there are all kinds of options there. Anyway, thanks for coming down. We're going to try to do this monthly. Hopefully there'll be enough community interest. We can all kind of get together and hack on different Elixir things. And at the end of the presentation, I was also going to put up some options for future discussions. Get more into that. There's a lot here. So anyway, go ahead and get started. Elixir is a functional programming language. It's inspired by Ruby in a lot of ways, and it's extensible. And Jose, the guy that created it, he was a Rails core contributor. And one thing that's super important for him is to be pragmatic and have really great tooling. So once you install Elixir, you get Mix, and Mix helps you get up and running very quickly. How many people are familiar with Ruby on Rails or Ruby in general? Well, with Ruby on Rails, it's super easy to install it and then go ahead and just jump in and create a new project. Mix does this for us too. And then Hex is the package manager, so much like with Ruby, Gems, so it has sort of the same functionality. And it's actually been taken over with the Erlang community. And that Erlang is sort of the next thing I'm going to jump into. And one of the primary reasons that I think we, especially me, maybe everybody else on the team, I liked the fact that Elixir is built on top of Erlang. Erlang is much like Java in the sense that it compiles down into bytecode. So, and there's a rich ecosystem. It was developed in 1986, so it's been around for a couple of days. It was open source, I think, in the late 90s. It was primarily built to manage phone switches. So it's super robust. I mean, most times you pick up your phone, like especially old like landline phones, they always work. So it was built to have exceptional reliability. It's concurrent and distributed system, so it's super easy to add new nodes on. So anyway, built to run telecoms. So it's super fault tolerant. It has this idea of letting things crash. So you have trees of supervision. So a lot of times you have to rewrite, try-catch blocks, right? And try to handle everything there. Well, the idea with a lot of Erlang is to let that bubble up and have something sitting on top of it to sort of deal with crashes. Hot code swapping is something that's also super interesting. The idea being that you can push out a new build to production and not have to restart things. There are special things that you have to do to make that actually workable, because you have code that's running and new code's introduced, but it's a feature of the language. And then there's this idea of running the processes, and process in Erlang is not like a full thread that you have in other programming languages. It's all managed inside the Erlang VM, and they're super lightweight, super easy to spawn up, and it actually is, when you're thinking in terms of Elixir, if you think in like object-oriented terms like instance, you would typically do that in Erlang or Elixir. You can spend the process really making a state. Yeah, sorry.
So the threads you're talking about, they're not like operating?
Well, these aren't threads. These are processes. And I'm saying they're not threads.
Oh.
So yeah, they're much lighter weight than an actual thread. And there are examples of people spinning up like millions of processes on a single laptop.
So the way to think about processes in the Erlang VM is that the Beam VM, when it starts up, it creates a single process per CPU core on the system that you're running on. And then what it does is it kind of acts like its own kernel and schedules all the Erlang processes on those 4 core processes, or however many CPU cores you have. That's how many processes it handles scheduling.
And that's actually an important point because, again, you guys have been watching YouTube where you have like the whole Moore's Law thing is like kind of breaking down a little bit. Like we're not, CPU speeds are not increasing the way they were. So with Erlang and Elixir, you can actually utilize all the cores on your, on your system. And they're actually trying to do a lot of this. If you listen to some of the talks they're doing about, the next version, like Ruby 3, right? They're trying to get at this problem, but that's one of the reasons I think a lot of people like Elixir is that, if you're coming from a Ruby or Rails background, Ruby is not good at thread, right? It's actually, in the first versions of Ruby, it wasn't even possible really to read thread. So, this is an easy way to get, or an easier way to get to that people report that there are 9 nines of reliability with Erlang, which is like, I don't know, seconds of downtime over 20 years. But it's for a very specific case, and you can tell one switch. But anyway, it's interesting to think of a piece of software for running for 20 years without, crashing and so on. So anyway, it has what's called soft real-time, which is like a lower level of real tininess than real time, but it's close to it. It excels at parallel processing. So again, if you think about utilizing all your cores, and then again going back to distributed processing, it's easy to network and add new nodes when you're using Erlang or Elixir. One of the things that really blew me out of the water when I was kind of looking at this was pattern matching. I'll talk about that more in a little bit, but with Elixir or Erlang, with pattern matching, you're not actually doing assignment, you're matching a pattern, and I'll show you some examples of that. That was like one of the first, because I read this book first. I don't know if you guys read this guy Dave, Dave Thomas. He did a book on Rails, kind of like catapults and Rails out there. And he wrote this book, and when I was first reading this book, I kind of started reading more about pattern matching. I was like, wow, that's super powerful. But anyway, so you also end up using recursion quite a bit, obviously, with functional programming, and I'll show you some examples of that.
In fact, Erlang doesn't have any such thing as a loop structure at all.
Well, yeah, we'll talk more about that. It's garbage collected, just like Java, other languages out there. And then I was just jotting down some things that I found that are using Erlang. So CacheDB, React, SimpleDB, which is an Amazon product, RabbitMQ. You guys heard about WhatsApp, obviously, right? So WhatsApp sold for billions of dollars. It was all written in Erlang. It had millions of concurrent users, and I think they had like 10 engineers or something crazy like that. I think it powers Facebook Messenger now too. It powers a lot of backend systems, so Call of Duty, League of Legends, some other systems like that. Part of our thinking, and just so you guys understand why we picked Elixir and thinking about it, is because as we're redesigning Derby Wars, we're very much more thinking about it, as a game. So our Elixir system will be our back end, and then we're just going to plug into it, with iOS, Android, heavy JavaScript type stuff. But, so we definitely like the scalability of Elixir. It's built on top of Erlang VM. There are a number of other languages built on JVM, Clojure, other things like that. So we took a strong look at that as well. So a lot of fault tolerance, but another huge factor for me was the community that's been growing up around Elixir. Jose was a branch contributor, and he actually created Elixir after I think he was trying to do some kind of like pub sub stuff with Ruby, and it was a huge pain in the ass. So he was like, the whole thing about Ruby is it's supposed to be a joy for developers to program in, and he wasn't joyful. So he was like, what can I do? So he started looking at at Erlang, and saw a lot of things. He felt like Erlang was missing a lot of things that he'd like to see. So that's why he created Elixir. There's another framework that sits on top of Elixir called Phoenix. We're also looking at that. It does some pub sub, socket stuff, but it also does a lot of Rails things too. So anyway, there's a really great community out there. I've joined the Slack channel and asked a few questions. People are super responsive. They seem super helpful. Anyway, so that's important for me. We already mentioned parallel processing using all our cores on our system, which we don't end up doing things like Ruby. With functional programming, you have immutability, which is super important, especially as you're doing parallel processing. And we'll talk about that a little bit more. I'll show you some examples of this with Mix, because you can tell Mix compile, and basically goes in and takes your EX file extensions, compiles those down into bean code, generates files just like JVM would. And so if you do want to write an Erlang, you can go back and forth between Erlang and Elixir, because they're talking in the same file. But again, I understand there might be some compilation optimization type things, but the basic idea is that it's sort of one for one. You're not like bridging something back on. Again, Jose was trying to recreate that Ruby joy when you're programming Elixir, which I kind of like. I also like looking at functional programming because, probably like most of you guys, I've been an object-oriented programmer for a long time, and so I like being forced to think in a different way. So with functional programming, you're trying to create like small composable pieces that fit together. And one really powerful thing that I was reading and thinking about is they were talking about the way Unix CLI programs are written and how powerful it is to be able to chain those together. And so I think that's one of the sort of the core tenets that Jose was thinking about when he wrote Elixir. So I like that small composable fitting together thing. I think that's a really powerful concept. Anyway, functions don't mutate data or have side effects, and I'll kind of walk you through some of that and talk about that too. So one of the other things that was really cool was the actor model. I don't know if you guys have been looking at other functional programming languages, but it's kind of a cool concept. It's more advanced, and it's something that I think we should probably delve into in later talks and that fits into an introductory piece. But anyway, I already mentioned how fast and lightweight the processes are, and literally creating like millions of processes running even on your own laptop. The tooling was super important when they were building this, so you're able to get productive fast. So Mix has a number of functions. You can tell everything does compile down into bean code. So compiling, I'll talk about dependencies. So dependencies, if you're working with Mix, function much in the same way that Ruby gems do. If you're familiar with that, so you bring in alternate libraries, testing, so there's mix unit, and then you can quickly create new projects with mix. And then even like if you take something like Phoenix, it uses mix and you generate some more code. And I can show you some mix stuff too. Well, again, this is an intro, so we're super basic here. So forgive me if you guys already know all this stuff. And you said you own all the books. So. Anyway, the basic types in Elixir are integers, floats, booleans. Atoms are much like symbols in Ruby. Strings. So this is kind of a departure from Ruby. Strings. You have those, but then a single quoted string is a car list. So actually, if you're playing around with car list, it's trying to print out the letter representation of the number. But the strings are actually just like a collection of you have binaries as well, and you can see the notation for that. I saw this really cool example the other day of using pattern matching with binary to take PNGs and like extract all the header information out in like very little code. Just using pattern matching is super powerful.
That's how Cowboy does a lot of its press parse.
Sure. But yeah, I mean, and that's kind of where you get into like all the stuff you can do with pattern matching that like maybe you don't think about when you first look at pattern matching, but when you really like go further with it, it's kind of amazing. You have lists, so an array basically, and then as you're working with recursion, there's a lot of head and tail. So that's what those notations are: HT and TL. So you can actually work with the pieces of that list. Tuples, and then maps, so key value pairs. And with maps, the keys are unique. We have all of our standard basic arithmetic operators. So the division and remainder just return integers. There's and or, just kind of like Ruby and regular or and syntax and not. And then you have the same basic evaluators that you do in most languages. The triple equal, just like JavaScript or whatever. So if we had an integer, it's 1, and then we had a float that's 1 out, and we compare it. 3 equal signs, it's not going to be equal. And then you can do the double minus is a diff. So you can diff lists and other things, and they have different functions based on what the types are. You can concatenate lists with them. And then Elixir, unlike Erlang, with Elixir you can reassign variables. Right, but if you put a caret in front of the variable, then you can't be reassigned. So just a special. So I think there's an underscore for digit separators. I'm sure actually why I have that separate slide at this point. Anyway, pattern matching, sort of like super cool feature, or one of the super cool features for me. LHS and RHS, left-hand side needs to match right-hand side. If things don't match, it'll actually end up throwing errors. So, like in this example, where we have ABC 1, 2, 3, right? So that will match, and then each of those values obviously will be 1, 2, 3, but it's really not an assignment as much as it is that matching the pattern. So that second example, we only have 2 things in the list. It won't match, and it'll throw in an exception. So, like I mentioned, the concept of head and tail is super important. So if we IX, hopefully this isn't too blurry for you guys, but syntax. Does that need that at all, or is that still screwed up?
Bigger.
Better?
Yeah.
Okay, sorry about that.
What's IEX?
Good question. Okay. Yeah, sorry. IX is the interactive shell for Elixir. So I just ran the basic command, which is IEX, and I'll show you some of the other commands later. You can incorporate it with mix so that it'll actually check your path, and you can load modules that way. And I'll talk about that a little bit more in depth. But anyway, so this syntax here, where we have the pipe operator separating the head and tail. So the head is whatever's in it, and tail is everything that's left over. So 2, 3. And it seems simple, but with recursion, this is actually a super important concept. The head and tail, as we're basically doing our looping. So
Those are keywords that,
No,
No,
those
I
are just
can call
variables.
Bob and John.
They're bindings.
Yeah,
So
it's pattern matching to those two pieces. That's just the pipe operator is the only really important piece.
You said it's a binding, so is it actually a copy or is it a pointer or
it's just the value.
it's the actual?
So it's not.
And yeah, I believe, okay, now we're getting into the finer points that I might not be 100% on.
That's fine.
But I believe that what it would do is it would allocate its own stack for that, like its own memory allocation. Because we'll talk about recursion, and then we'll talk about tail call optimization and some other stuff. So that actually is kind of
The Beam VM values by default are single assignment until you flush them. So if you assign a value, it exists throughout the entire Beam VM until it's changed. So it allocates it once in memory and keeps a record of that in the stack.
So 2 exists and there might be multiple pointers to 2.
Well, head exists
Sure, yeah, in this case.
as a single pointer, and you could have multiple places in the code using that pointer. But it can't be reassigned or changed so that you don't have concurrency issues, race conditions.
So I mentioned earlier that variables can be rebalanced, so that's what I'm doing here. So we declare x, match it, or we match x to 1, and then you can use a semicolon to have multiple statements on one line, and then we just match x with 2, and Elixir's happy is fine about that. But in Erlang you can't do that. So. But if you want to prevent that from happening, you can use the error, and then it will actually throw the error if you try to reassign. The other thing I want to show you guys is the underscore, and this is used in a lot of places in pattern matching. So basically, the underscore says, I don't care about that value, so throw it away. So you can't, once I match on an underscore, basically it's thrown away. I can't even reference that and get the tail from it. And as you're working with Elixir and you're compiling your code, if you do have variables that you don't use, it'll warn you. So a lot of times you'll end up using underscore to just say, I don't need that match, get rid of that, and get rid of my compiler. So maps are pretty cool, used in a lot of places. So the value pairs, obviously just sticking my name in there, first name, last name. You can reference it, and if you're familiar with Ruby, so same thing basically with an add-on there for first name, which again, if you think about Ruby, is just the same thing. It's like simple, and then you can also use dot syntax The last thing it's doing is basically what I'm doing is taking a map called me, and then I can change the first name this way. The result of that, it's just changed capital K from my last name. Okay, so there's the idea of structs, which are contained within a module. And the main use I've seen for this is just so you can have like parameterized arguments. It's called arity in Elixir land. So the arguments for your method, for your function, it's just called arity. I have no idea why they chose that.
It's from mathematics.
Okay. But anyway, so a lot of people want to declare structs, so that way we can have sort of like hard parameters to our module. Structs are basically maps, but they don't implement all the map functionality, so don't expect them to do everything the map does, so it's just like a very simplified version of the map. So control flow. I'll mention this briefly. There's a concept of macros in Elixir, and what macros are basically allows you to do metaprogramming. So there are a ton of macros in the actual language itself to define language, and all the control flow mechanisms are macros. And basically, because Elixir is a functional programming language, you're not encouraged to use a ton of control flow. So you do have if-else ends, right? You have case statements, like many other programming languages. They add in an else and unless, just like Ruby. There's a condition statement, and basically a condition statement is like an if-else statement. The idea that basically you're having a bunch of extra else-ifs. And then there's the try-catch. Again, you're not really like encouraged to use a lot of those statements. So what you'd use in a lot of cases, just basic pattern matching. I'm gonna hop out some code here for a second. So this is an example that's in a lot of places, and I shamelessly stole this from Dave Thomas. So, but when I saw this, I thought this was really cool code for pattern matching, because I guess BizBuzz and other languages, right? There's a lot of like, yeah, what's BizBuzz? BizBuzz is a test that used in a lot of computer or programming languages just to see, like, you know, if you can code your way out of a paper bag. But the idea is that, like, if a number is divisible by 3 or 5, if it's divisible by 3 and 5, then print BizBuzz. If it's just divisible by 3, then Biz, just divisible by 5, Buzz. None of the above, and just print the number, right? So that's what this is doing with a case statement. So it's using pattern matching to say, here are my parameters, right? Remainder 3, remainder 5, and then the number itself, right? So if it matches, if there's no remainder for both, then print this one, right? So that's like the whole concept here. And to me, with no like conditional logic, like, you know, if else everywhere, it's super succinct and it easily gets across like what it's doing. And this is just a helper so that we can pass it number and have it map that out. Another important piece of that is, we'll talk about names in a little bit, but if you're familiar with like a map function in Ruby, basically it's just gonna iterate over this. So I should probably jump back and talk about this right here. So that's a range. So it's just defining a range dynamically from 1 to whatever n is. And then it's using the pipe operator to pass that into the name.map. And so what happens here is that that range from 1 to, let's say, 5 is passed into the first argument of a name.map. So basically, as you're chaining together using the pipe operator, whatever is on the left-hand side becomes the first argument to the next function on the right-hand side. And so it's also using, okay, right, you're thinking what that's called. Sorry, brain freeze. I'm trying to remember what it's called when I'm using the ampersand in the function.
Function capture.
Yeah, capture. Right. So it's using a capture, and that's also more Elixir syntax. So it's doing /1. That means I know my arity of the fizzbuzz function is 1. So it's automatically passing each item from the map function into my fizzbuzz function. So anyway.
But isn't a map a key value pair?
No, that's a new.map.
Okay.
So that is actually basically the blue number. So if we go. So instead of just invoking the regular X function or the regular IX, I'm telling it to use mix, and so basically that loads up everything in my path, so that way I can easily reference my files. And I'll show you guys mix in a little bit, but anyway. So this is printing out. You can also, once you're in IX, you can also reload your modules. So much like in Rails, if you guys are used to IRB, so you need to go out, if you change the file and you want to go out and add a new function to it. So now it's available to me once I've reloaded the module. If I hadn't reloaded it, it'd go, I don't know what the hell this is. Anyway, that was like one of the first things where I was like, wow, that's super cool that you can have really compact code that calls a couple functions and there's not like 100 lines of if else. So anyway, it's one of the things I like about the language. So jumping back into functions, Eric and I were Eric was shaking his fist at anonymous functions today. The basic concept is you can define a function, and that's what it's doing here. So it's just creating a function called square. Simple, just with the fn doing simple multiplication. But then it's called with the dot syntax, so that's how you call it an anonymous function. I don't get the huge use case for anonymous functions personally. And it's probably just like maybe my maturity with the language, but it's really good. I'm sure there's some like super awesome use that I just haven't figured out yet. So you guys know one?
Mainly keep your other functions smaller. You can factor them down like in Ruby. If you had a big method, you can just break it out into lambdas internally. So it allows you to give that option.
I would argue that the best use of an anonymous function is to pass into some sort of map or reduce function.
I was about to say, that's what I use.
And passing functions to functions.
Yeah.
That way you get lazy evaluation. You only evaluate it once you absolutely need the value.
Well, I mean, that's what streams are for. Okay. sorry, I'll jump back out into guards. Guards are like a super important piece so that as you're calling methods, basically, or functions, you can, if you have a guard, then it'll be evaluated and it'll call the appropriate function that matches the guard. So this is just an example of using guards. So basically, it's going to do some type checking to figure out what's due based on the arguments passed in. So all this is doing is saying, if I get past 2 integers, then add them. If I get past 2 lists, then concatenate them. And then it's checking for binary, concatenating them. This is kind of an important concept too. You can have default values for your function. So that's just done with double backslash. So it's using my default value for. It's actually getting later. So we're going to do a free game for you guys with my running over. You guys probably didn't come here and play a free game, so there's also the concept of partials. So basically, it's a convenient function, or it's a more shorthand way to call functions. So that's all it's saying here is I define a function called square, and I'm taking a list of 1, 2, 3, running math against that, and then calling my square function on that. So it's a more concise way to call a function. It's also second example. There's also comprehensions, so you can do. It doesn't have to be a 4, but all this last statement's doing is matching my list of 1 and 2 to X, and then looping over those and multiplying them together. So.
Is that actually returning a new list?
Yes. Okay. Yeah, absolutely. I can.
What actually does that what syntax says do a comprehension? Is it the left arrow with the dash, or is it the 4?
Yeah. Well, the 4 is a piece of it. You don't necessarily have to do a 4 with comprehensions. I think there are other things you can do, but it does absolutely. Actually, I mean, anytime you're calling a function, I mean, it should be returning something new because you're not mutating the state. So. So enums are used in quite a few places, and I'll talk about recursion later, but enums are sort of, they help you get away from a lot of boilerplate recursion, and you can do a lot of functionality and do a lot of things with enums. And unlike object-oriented programming, instead of like, I mean, a lot of times when you're dealing with stuff, and let's say Ruby, like you might have a string and you might just call length on your string, right? Get back to how many characters you have. But with functional programming, you're going to pass your string to a function that then tells you what the length of your string is. So, but in this example, again, you're using the type operator, you're using math, you're using comprehensions, and the idea, and I can actually just So I just wanted to show you guys some of the difference between names and streams. And I'll talk about like what that actually means. But again, I'm still in all kinds of code around that. The basic idea here is to use an name to sum all the numbers between 1 and 100,000. There are 5, and then some of all that. But and I haven't talked about streams yet, but the basic idea here is that they both end up with the same result, but the names generate many intermediate lists as it's doing all these different type operators, whereas streams are not, they're lazy, and so they actually only take what's needed to perform the functions that they're running through. So meaning that with the names, even if the number is not odd, you're still going to be running through each one. And then there's a slightly different, and if you're in IX, you can see that if you're working with streams, it's actually returning a function. And you can see IX printing out that function. Whereas if I'm working with the names, then it's actually showing me the full list of what I was working with. So.
Is this analogous to like a generator or? Yeah, like streams are basically a generator. In the value and passing it, not necessarily one at a time, but as it's able to. Or
as it's speeding.
yeah, and so it's not generating the entire list.
Right, yeah, so, yeah, okay, sorry.
Yeah, if you see there, when he did the streams method, or the streams function, it's returning a record, and it has the range that he wants to span over, the enumerate over, and then a list of functions that he wants to run over that list. And basically, if he doesn't need every single value within that enumeration, it will only do what's needed. So basically, it will let you, let's say if you want an infinite list of numbers, but you don't know how many you need at the end, you can use the stream to let you process that infinite list.
Yeah, the list doesn't exist in memory. It's only creating a single integer.
Right. And I actually have a slide for this later, so I apologize for kind of going out of order, but, and so something that speaks to this point is, so I did an example with streaming a file. So the idea here is that I'm using a string to open a file, and I'm only going to take 10 characters from it. So if the file is like, 100 gig, right, with the stream, I'm only going to open up as much as I need, rather than opening the entire file first and processing. So that's kind of okay, so names are easier, as we discussed. So if you're opening a file, then you would name it. Whatever, it's going to take the entire thing rather than just switch to streams. I'll talk about recursion a little bit, but names are higher order, or built on based on file like recursion, so you can do a lot of things within a name and like bypass writing a lot of world like kind of recursion. Yeah, so streams are lazy. It's good for large or infinite data. It implements the name protocol. And we're not really going to discuss protocols too much here, but in Elixir, there are the ideas of protocols and behaviors. Protocols basically allows to have polymorphism, functional programming. So kind of what you're saying, yeah, it describes my computation rather than like doing the whole thing right away. Okay, so recursion. What's that? Hey, Eric, what's that guy's name? Devin. Okay. Yeah, Devin was talking about this, like in Elixir or in their language. So anyway, in Elixir, when I call a function, I don't mutate. So anyway, so looping is done via recursion. A lot of times you'll have an accumulator, which I'll show you, and that will hold the value of what you're doing as you're doing your recursion. There's a thing called tail call optimization, so that you minimize the space that it takes. And I was reading about this and I'm talking about, if you're recursing over a really large data set, you want to make sure that you optimize that in tail recursion so that you minimize the amount of space you're taking up. Mention that about names being able to help you not bother with doing recursion, and this is just showing you enum, reduce, and passing a function. And it's using an accumulator, that's ACC is just shorthand for that. And so it's adding up all your values. It's using an accumulator in there, enumerations. Turn back. So this is an example of recursion to sum a list of numbers. And so each of these functions has the same name. And so what this is doing is this first sum function is basically your entry point into the recursive loop. And it takes a list and accumulator, and it's going to default that accumulator to 0. So if I wanted to start from some other number from 0, I can pass that in. The next function is actually the last thing that can be called. So this is an example of tail optimization. So as long as the last thing called returns the value, then it's tail optimized. And then this is where more of the meat's done. And you can see it's using the head and the tail. So as far as the area is concerned, it's taking the head and the tail, splitting that out, it's accepting the accumulator. It's then going to pass the tail of the first piece of the area, and then add the accumulator to the head. So hopefully I'm describing that kind of okay. I mentioned processes, and they're kind of like the same thing. You use them to perform much the same thing you would use an instance for in object-oriented programming. I'd really like to do like another talk on this, and maybe Eric will do the talk or Ed. But anyway, the concept of being able to quickly spawn processes, and this we can use message passing, which is a huge feature of the language, so that they can communicate. And that's part of how it becomes distributed, because you can spin out processes on different servers even that are all communicating together. Spawn link is actually probably used more frequently from what I understand. And that way they can get linked. And so like one process crashes, another process can be notified if that's the case. Again, they're lightweight, cheap to create, super fast to get done, not OS threads. Testing, there's a thing called EXUnit. It's unit testing for Elixir. It's integrated with Mix, and it has all the things you generally expect, insertions and things of that nature. So anyway, I only have one unit test, so it's not gonna take very long.
You get one test though.
Well, Mix automatically generates its,
Is it the 1 + 1 = 2?
Did you change it in any way?
I did not,
Well,
but, I'm just trying to get ready for this. 1 + 1.
The old one that used to just be a search tree.
So anyway, it comes prepackaged. Yes. Now I'll go ahead and show you Mix, and this ran a little bit longer, so I apologize if you guys were tears. But so the other thing I want to show you guys, there's automatic document generation. So we look at Mix, and just real quickly, there's a lot more to Mix, so I'm not trying to like template on all the crap you can do in here, but. So I have a lot of information about your project. Sorry, I'm used to typing, not talking. You can tell the application like all the other things that are going to start and work within your project. And then we talked about dependencies a little bit. Again, much like Ruby Gems, same kind of idea. So you can include some things. So this is adding xdoc, which is a document generator. Again, use Mix to generate your documentation. And then you can just do anyway, that's not supposed to happen, but moving on, you can generate your documentation. I've been really surprised at how good the documentation's been, because Elixir being a very young language, there are like a billion Ruby gems, right? There's a lot less in Elixir. Of course, you can lean on Erlang, but anyway, so. I find myself reading a lot more source code with Elixir than I did with Ruby. And so I've seen some really good documentation, which I'm grateful for. So I'm almost done. So there's a ton of other stuff in Elixir. There's OTP, actors, protocols, behaviors, macros, metaprogramming. If you guys are still interested in being able to talk about this stuff, we could like work together to pick other topics. Certainly better speakers than you can present and do stuff. I tweeted out a link to the GitHub page for this presentation and my examples, such as they are. So feel free to download these or get stuff. But, so this play by example, so you can run IX and Elixir from your browser and you have to install it. Dave has cheat sheet. There's a Slack channel. And then I was going to, I don't think this is going to work out for me because like a lot more people signed up, so I have a lot of extra things. So we're going to pick our winners, but it's probably not going to work out for me very well. Wow, who would even think of that? Okay. Anyway, so if you guys have a 6, 8, or 7, or if you just want a book, or you don't care, that's okay too. But anyway, I just was doing some stuff. So this is actually a call to Erlang. So if you do colon, and then this module, and then function. So that's calling Erlang, and I'm just getting a list of however many I typed in, I think I put in 14. And then it has a shuffle, and then take 3. So just take 3 numbers.
Is there like, do you have to do any sort of, how does Elixir know about modules that exist? Do they exist globally in the system? Is it
No, so,
create like a
so
virtual environment of some kind?
yeah, so I was cheating. So I typed in IX dash word or dash uppercase S mix, which actually will load everything from my path and it's in my mix file. And so that's how it knows to be able to call that module.
So Mix has some sort of file that's declaring dependencies of some sort, or is there?
The way I understand it, it's looking at the path. So it's saying everything that's within this path will show up.
The current path? Got
Yeah.
it. Okay.
So
When I think path, I'm thinking like a shell path.
right. Yeah. So that's right. If you see me like quickly like flipping back and forth between directories, it's kind of cheap because I have a bunch of different mix files. So that's how it knows which modules to.
It does it based off of the directory. So the next tool itself compiles all of your source files into bean code and it structures them in a certain pattern in each code directory. And so it uses that whole directory to pull those.
So
it reads all of each file.
if I look at my file system, you can actually see that it's compiled. So that's all I got, guys. Anyway, if anybody has 6, 8, or 7 wants to look, or we can. No? All right.
I'll take a look.
I got an 8.
Huh?
I got the 8.
All right, well, since you have an actual number, why don't you pick one you want?
Take the inaction. I got the other ones. That's a good one. Thank you.
That's it, I'm reading that one.
I'll bring it back when I'm done.
Okay. It's kind of a
Go ahead.
library.
Take that green one?
Huh? Yeah. Anybody else want to vote?
Let's get started.
Nobody wants to vote?
Did you want it?
Yeah.
Yeah. Okay.
Yeah. Thanks for coming out, guys. Sorry I ran way later than I wanted to, but it was kind of up here blabbing, so. Yeah.
What's your action?